Yet another type of data is self-referential data, which is also known as recursive data. So in this video, we'll be defining an example of recursive data, and we'll be using it in a function. So to start off, I've copied over our data definitions from earlier videos. So we have a species, which was an example of enumeration data, and a person, which is an example of struct data. And we'll be using both of these types in our new self-referential data. So I want to make some kind of structure that can represent a family tree. So let's define struct. Let's call it tree. And for the fields, it can store a person, and then their mother and father. So then, following the steps of the data definition, we write a family tree. That's going to be the name of our new data type. We can also call it FT for short. Is one of. And here's the self-referential part, because a family tree can be a make tree, person, family tree, family tree. So within a family tree, we're storing two other family trees. And so because your mother and father will both have their own family trees, so this is an example of self-referential data because we're using the data type within its own definition. And this will make sense in a little bit. And now this is also an example of union data because we want to use the Boolean value false to represent a family member whose information we don't yet know. And in our interpretation, let's say family tree represents a person and their known family tree. Now let's define some examples. We'll start with the unknown family tree. And this will just be the Boolean value false. And actually, we don't need those extra parentheses here since we're not defining a function. Now let's make some examples for Spock's family. So let's do family tree, make tree, done. And let's say we don't know about his father or mother. Let's make 3 more examples here, one for each person, one for Sarek. The person is Sarek. The father of Sarek, the mother of Sarek we don't know. The father of Sarek we have defined above as Scon. Let's define Amanda's family tree. Let's say we don't know her mother or father, so we'll have both of them as false. And finally, we define Spock's family tree. And Spock's mother we'll say is Amanda, and Spock's father is Sarek. So these are examples of family trees. We have 4 examples. So let's write now the template for this data definition. So I'll call it fttemp. We'll take in a family tree. Start with 3 dots. Our conditional statement. First thing we want to test for is this a Boolean, Is ft a Boolean? If it is, we want to return something based on that information. Otherwise, is it a tree? If it's a tree, then if it's a tree, we can take out the person from this tree, the root person. And since that root person has the type of person, we can use our person temp from above. dot, dot, dot. Then the next thing we want to take out is the second field, which is the mother. So tree mother. And since the data type of tree mother is a family tree, so then the template we would call is the FT temp. Dot, dot, dot. And same thing for the father, FT temp tree father. So now we've accessed all the fields of family tree. We can finish off our template. And now to demonstrate using recursive data or self-referential data, let's define a function called oldest member. This will take in a family tree and produce a number representing the age of the oldest person in this family tree. So let's write our purpose statement. There's the age of the oldest member in the given family tree. And let's say if there's no known members, let's just return 0. So let's write some tests. So the family tree includes the root person and every one of their ancestors. So if no one in the family is known, no one is known, we just want to return 0. Let's say for Spock, we look at the entire tree and we look at all the people, and it looks like the oldest person will be Scone. So we're looking at Spock's tree, Scone at 300 years old. And let's do one more example. Let's look at Amanda's family tree, where we don't know of any of our ancestors, so it should just return Amanda's age, which appears 150. So now let's define our template. We take in the family tree. To make this a little bit easier, I'll copy the template. Sorry, we're not writing our template, we're writing the function, the body of the function. So we copy over the code from the template, the family tree template. If it's a Boolean, we don't know anyone in the family, we can just return 0. Otherwise, if it's a tree, we want to return the max of the age of this current person, the max of the age of the current person, or the oldest person in their mother's family tree, or the oldest person in the father's family tree. So this should hopefully give us the oldest person in the root person's entire family tree, in the entire family tree. So now if we run our function, we can see indeed we're getting all the values that we're expecting.